This year's fifth inductee is the late Dr. Stanford Moore. Born in Chicago, Illinois in 1913, Dr. Moore graduated from Nashville's Peabody Demonstration School, now the University School of Nashville, and Vanderbilt University, where he earned summa cum laude honors and was a member of Phi Kappa Sigma. He received his doctorate in organic chemistry in 1938 from the University of Wisconsin-Madison, before going on to become an accomplished scientist and professor. During his successful career, Dr. Moore developed many significant scientific breakthroughs that changed the way the world conducted research. In 1949, he published the first method for the complete analysis of the amino acid composition of a protein, redesigned an automated amino acid sequencing system, and contributed to the growing understanding of how protein functions on a structural and chemical basis. This work ultimately resulted in his 1972 receipt of the Nobel Prize for Chemistry in Stockholm and changed the field of genetic medicine throughout the world. Please join me in welcoming Kevin Lee, the co-founder, president, and CEO from Hall of Fame presenting sponsor Journey Pure, for the presentation of Dr. Moore's award to Vincent Durnan, director of the University School of Nashville.
It's a great treat to be here, standing in for Stanford Moore. I look pretty good for 104, don't I? So the personal narrative is this. He was the son of a Vandy law professor, went to his undergrad education right there at Vandy, thinking he'd be an engineer, but turning into a chem major, not as pre-med, but as a lover of the subject. Then to Madison, Wisconsin to earn a doctorate in organic chemistry, then up to Manhattan for basically the rest of his life at what was the Rockefeller Institute, now Rockefeller University, where as an innovator, he opened doors to knowledge about how our DNA determines through RNA and other structures of proteins a range of biochemical reactions and processes. Basically, how chemical molecular structure determines biochemical reactions. The really sad part of the story is that this brilliant scientist developed ALS, called by most of us Lou Gehrig's disease, an illness that affects neurons and has, ironically, no clear biological or chemical cause. He left no living relatives. He was single-mindedly devoted to his work. The larger story for Stanford Moore is a story of active teamwork and collaboration and problem solving. Early on, he met William Stein at Rockefeller Institute, and the two formed a long-time partnership. They had both gone to schools associated with colleges for teachers. Stan, as he was called, at Peabody Dem, and William at Lincoln School, now part of Teachers College at Columbia. Stanford was sent by his advisor at Wisconsin. In this room, his advisor was the guy who invented warfarin, by the way. He was sent to New York, where he worked with scientists who made their way there from Germany in the late 1930s. He and Stein developed ways to break down enzymes and understand amino acids, ribonuclease in particular. Effectively, they invented tools for a task. That work took him to Brussels in 1950, and even for a time back to Vanderbilt in 1968 as he actively sought out collaborative opportunities. It's a story for science's sake, supported by a university that stood committed to research, and by other organizations like the National Science Foundation and National Institutes of Health, turning discovery into health, as their motto states. Then, in December 1972, he and Stein and another American chemist, Christian Anfinsen, journeyed to Stockholm to be honored at the Nobel banquet, to split the prize 3 ways and each make an acceptance speech. At the banquet the night before, for all the laureates, Stanford Moore talked about, and I quote, the common bond which the search for truth provides to scholars of many tongues and many heritages. In the long run, that spirit will inevitably have a constructive effect on the benefits which man can derive from knowledge of himself and his environment. And here's part of what he went on to say about his discoveries in science. Such results afford an example of the manner in which one finding leads to another in basic research, and ultimately to possible benefits to man. When we consider biochemistry in 1972, it's important to realize how fragmentary is our knowledge of the molecular basis of life. Very few macromolecules can be discussed in details with which ribonuclease or hemoglobin can be defined. Such knowledge of structure-function relationships is basic to the rational approach to the intricate synergisms of living systems. He was a smart man, a humble man, a wise man. On behalf of the University School and our good friends at Vanderbilt University and all whom he inspired, I'm honored to accept this distinction on his behalf. Thank you.